Determining which power architecture to use is important in any electronic device or system. This is most certainly the case with industrial autonomous robots. The size, efficiency, weight, and scalability of the DC-DC converter will have a significant effect on battery life and operability. Today, we're chatting with Joel Zanes, product manager over at TDK Lambda, and Lisa Offrey, power system sales engineer with Sega Electronics, to discuss this topic and the options available. We'll explore using non-isolated versus isolated DC modules and provide solutions to maximize runtimes, talk about battery weight, scalability, and system cooling in these settings. So thank you, Joel and Lisa, for joining us. We appreciate your time today.
Good morning.
Hello. Good morning.
Thank you for having us.
Absolutely. All right. So Joel, why don't you kick us off? Let's start off by discussing the market at a high level. What are some of the latest key market drivers, for example, for AGVs, autonomous guided vehicles, and drones?
So what we're seeing in the market, Nicolette, is the AGVs and drones or industrial mobility. It's actually gaining traction due to the labor shortage that we're seeing, which is further exacerbated by the global pandemic. And then number two, it's basically increasing the efficiency of the manufacturers, for instance, right? You're seeing a global supply chain issue. Increasing the efficiency or the throughput or the output is actually one of the objectives. And then, of course, we cannot deny the fact that it always has worker safety in mind, right? For instance, in harsh environment, you don't want workers to be exposed into those elements. In the global pandemic, some areas like disinfection of some areas, you don't want your workers to be exposed in unsanitized areas. So those are the things that we see that's kind of driving the traction for mobility or autonomous robotics.
So as we mentioned, manufacturers are dealing with some challenges in this space. Can we highlight some of the main ones for the listeners?
Sure. Mobility, especially when it's autonomous, right? Usually they're driven off batteries. So the typical worry of a manufacturer, a robot manufacturer, is how long can I make my robot run, right? It's usually the runtime. And then second, which affects runtime, is actually the weight, right? The weight of the total robot. They've been adding things, making robots do a lot more things. They're adding features. So in effect, there's a trade-off of how much do I add and how much does that impact the weight and basically affect the payload and runtime of the entire robot. Now, because of those additional elements, additional features, especially now that there's more intelligence being added to it, there's also the problem of supporting those loads, those elements that are being added. So what comes to mind is powering those devices, powering those sensors, those 3D lidars and things like that. And of course, the amount of voltage rails present in a particular robot now. It's not just one or two, but we see trends like 6 voltage rails in a small, tiny robot with 6 voltage rails or even more. So those are the kinds of things that we see that are, that manufacturers are being faced with.
Now, you mentioned payload, right? So you have the payload of what's in the robot, whether it's carrying sensors or the equipment and the electronics it's carrying. But there's also payload, meaning this device is going to move something. Let's say, like if it's designed to drive something somewhere. Now, do you think people are designing them now, thinking about how those payloads may increase over time?
Yes, we've actually have partnered. We're working with some customers now wherein a particular AMR or AGV is requiring about 3,000 watts of power because they're anticipating all the added tools, added features that they have to claw into the AGV, those removable tops for added conveyors or robotic arms. Those are all going to be powered from the battery. So all of those payloads and then the load and the actions that it has to do would have to be factored in and accounted for in driving those loads.
So we know that over at TDK Lambda, you guys have some solutions, that you put out there to address a lot of the challenges that you talked about. Would you mind discussing some of those and talking about how they kind of compensate where there's an industry need?
Sure. So when we're talking about power modules or converters that's on the robot itself, right?
Mhm.
What we have seen is our brand new line of products, which are non-isolated DC-DC converters. It's actually gaining traction in this mobility market. Now, it's driven primarily by the higher efficiencies of these modules, right? So when you have higher efficiency, you have lower dissipation, less wasted power that's being consumed by the robot. So that means to say the battery charge that you have is actually optimized and utilized more for the load rather than being wasted. So that's one. Number two is some of these non-isolated topologies that we have, for instance, a buck converter or a buck boost converter, they lend itself well for battery operated equipment. So for a buck boost, for instance, that gives you the capability to regulate the output even when your battery voltage starts to discharge. So you're still able to maintain that output regulation, being able to run the whatever needs to be powered in the robot, even when you start consuming the battery charge. So those are some of the power modules from TDK Lambda that we're seeing more adoption and traction in the mobility space.
What makes this different from the other solutions out there?
So TDK Lambda's offering that are gaining traction in the industrial mobility space are our line of non-isolated industrial DC-DC converters, right? So this one is a little bit different from isolated converters because you don't have, number one, the isolation, right? Primary, secondary isolation. The feedback loop is much more simplified, right? So in effect, without all of these additional components, you increase the efficiency of the converter, which is important for battery applications, right? Higher efficiency, less dissipation. And number two, since you're getting rid of the bigger components like an isolation transformer in a converter, you're now able to shrink this. So it'll give you the lighter weight, right? Which is needed again for mobility, right? Addresses the lower payload, right? So efficiency, weight, those are kind of the challenges that we're seeing for manufacturers, for robotic manufacturers, right? So these are the areas wherein these TDK Lambda solutions are trying to address. Now, non-isolated converters, this has been prevalent in the telecom and computing space. What TDK Lambda has done is most of this new product line that we have tuned the input voltage ranges and then the output voltage ranges to actually cater to industrial loads. It's not going to be your typical 12-volt input for a server distributed power architecture that's used in computing or in server markets. But we're now training it more towards 24-volt, 48-volt input, or even 60-volt input, which is tuned to a 24-volt battery, 48-volt battery, for instance, right? And then our output voltages too, it's not your typical 3.3, 1.8, or 1.2 that drives silicon that is in the telecom and ICT space, but we're now tuning it, the output voltages of this to a much higher output voltages, which is, driving your DC motors, actuators, because the output voltages of these non-isolated converters actually runs from, say, 9 volts or 3.3 volts all the way to 60 volts, for instance. So it's a little bit different train of focus in terms of the load that it's powering up, which is more geared towards industrial.
So then what makes it smaller and more cost efficient and more efficient? How does that work?
Well, the being non-isolated, as I mentioned earlier, you actually get rid of a lot of the components that are not necessary for a non-isolated converter. So with all of those additional components and support circuitry that dissipates power, you're now freeing that non-isolated module with that excess components, right? And then you're freeing up more space. So instead of being, say a quarter brick size for a similar amount of power, you're probably going to be able to shrink it to a 16th brick size, for instance.
So that will reduce the size, then reduce the cost. And
that's right. So you're getting rid of components.
Got it.
Beefing up efficiency, scaling down the size, lowering the weight, and lowering the cost.
So talking about isolation, is isolation between input and output needed? Can you talk a little bit about that?
For industrial mobility or the industrial robotics, I mean, these are all being powered from a battery source, right? So typically you don't need any isolation from there. Everything's get powered directly from the battery. So in this case, it's not needed.
And what about thermal challenges? I know that this is another big one for engineers. How do we deal with that?
So that's a good point, because if you look at some of the deployment of this robotics, right? I mean, for instance, it's going to be deployed outdoors in a wet environment, right? Or even in a rocky terrain, for instance, exposed to the elements. Now, usually for these kinds of applications, fan is not desired, right? You don't use fans. It collects dust. It could fail. Eventually, it will not cool your system. The system's going to fail. So, in our product line offering, we've actually have three types of packaging. One is open frame. One has a conduction. One has a base plate for conduction cooling, and one has heatsink fins for convection. Or in the event there's forced air, then you utilize some heat sinking. But usually, what we see is for these kinds of applications, exposed to the elements, no airflow, dirty environment, then the contact cooling or the conduction cooling mechanical configuration with a base plate or enclosure is kind of suited for this dirty environment, right? So that's kind of the options that we provide. We tailor it to what the customer system cooling is.
So you did mention some of the temperature ranges, right? Things that are outdoors, and there's a degree of temperature ranges, right? There may be a big swing in some places that some of these things are being used. How does an engineer sort of think about the environment it's going to be in and sort of those temperature changes that may affect the life of it?
Well, I mean, in our case, our parts are actually widely rated. So, for instance, it's minus 40 to 100 degrees C case. So, for as long as our or the customer can guarantee or ensure that the base plate is going to be cooled, or the temperature of the base plate is going to be maintained below those maximum ratings, right? Whether they attach it to their own metal frame or cold plate within the frame of the robot itself, then they're going to be guaranteed that the device or the converter is going to be able to support their needs within that guaranteed operating temperature range.
So what are some of the other future applications you see happening?
We're talking about robotics, or we're talking about power supplies?
Robotics, power supplies, anything.
Well, I mean, we've seen it's been fun working with various customers that are involved in various spaces, right? Especially implementing robotics. I mean, what I think the most prevalent that we've seen is more of the warehouse logistics kind of AMRs, right? But some of the niche fun stuff that we see are, even in hospital applications, you've got some AMRs not just doing the disinfection of certain rooms, but even some of them are delivering linens to each of those hospital rooms. So a lot of unique applications. I mean, we've been working with a few drone companies wherein they're doing wind turbine inspection, right? So rather than sending a crew, maybe being lifted from a crane or crawling up or climbing up the tower, that maybe takes half a day or practically the whole day for one tower to be inspected. You just send a drone up, do the inspection, be done in 15 minutes, and then all your data is transmitted to the cloud. And then they do their own, software analytics. Oh, this one needs to be scheduled for preventive maintenance. The blades needs to be replaced. So a lot of fun stuff that we see with various kinds of applications. I think there's endless applications here, especially as the industry realizes shortages of the labor force. Then people are going to be creative, I think, and a lot of this are going to be adopted and designed for a lot of applications that I don't think we haven't even touched the surface of this.
Right. It's just at the beginning. It's just at the beginning of how we could use this type of technology.
Yeah.
Well, don't you think that drones are being used for a lot of surveillance type applications as well? I have a customer that's involved. They're doing a drone that's being used by farmers to send out to check their crops, to see, how the fields, with the condition of the fields, whether they, need cultivating or what have you. So they're being used for a lot of different types of applications today versus, just delivering our packages from Amazon.
Yeah, absolutely. I mean, if you even think about this, the drones seen, but think about how even like the rovers are used on Mars. They're testing soil. Like think about that from that farming application, where the drone could go out and test the soil. Is it moist enough? Is the pH right for growing conditions?
Well, I think, these robotic type vehicles have been used for years. Think about the military applications. The first in the door robots have been around for 20, 25 years now, where they're sending the robots in rather than, sending the forces in to check a location. So.
Yeah, absolutely.
So Lisa, I'd like to ask you how the Sager TDK relationship kind of works and supports this initiative. Could you kind of clue us and give us some insight into how you support this set of solutions?
Absolutely. Well, TDK Lambda is one of Sager's larger power lines, and we work very closely with the local manufacturers representative channels in the various areas, as well as TDK technical support. One of the advantages that Sager has is that, as we've been discussing, a lot of companies are experiencing a reduction in workforce. Well, it's not just on the manufacturing floor, it's also in the engineering personnel as well. I mean, there's fewer and fewer people being in a lot of these jobs today. So one of the advantages that Sager has is that we have a field salesperson who will be, perhaps speaking to one engineer who's looking for a solution. And then in turn, we can work as a PSE, power systems engineer, to find that correct solution for the engineer. So it saves them a tremendous amount of time. And we work in conjunction all the time with TDK Lambda.
Can you tell us a bit more about Sager and the power systems team that you just mentioned?
Absolutely. Well, Sager Electronics, we're about a $375 million company. We're owned by Berkshire Hathaway, and we are part of the TTI family of specialists. That being said, Sager Power Systems, we're a specialized group within Sager Electronics. We're about $125 million in sales, and there's 14 power systems engineers floating around the country. And our responsibility is to work with the engineers at the OEMs and helping them define their power, thermal, and battery solutions. In addition to standard solutions, we also have our 2 custom solution centers in which we work very closely with the design engineers in our own facilities and the engineers at the OEMs to come up with the correct solution for the customer.
All right. So then, Lisa, what value position can Sager bring to the customers for their total solution, given all that you have at your disposal?
Well, first of all, Sager is a franchise distributor. And that being said, we keep about $85 million in inventory. In addition to that $85 million, we have about another $180 million on order. So our stock position, our inventory position is in place to support our customers' supply chain. So that's one piece of it. The supply chain piece is one piece of it. The other part of that is the fact that we do have a technical sales force. We are probably one of the few franchise distributors or distributors out there that have a true power, thermal, and battery program. In addition to our battery and power program, we also have our custom solutions center. In our center in Lisle, Illinois, we do custom battery solutions for customers. So we do, we determine what cells they want to work with, the chemistries, and we design the battery management system for them. That's on the custom side. We do also, on our distribution side, we also have at our disposal 2 lines of lithium ion and lithium ion phosphate batteries. The lithium ion phosphate is used very frequently with the automated guided vehicles. And the lithium ion phosphate is preferred these days because, again, we discussed how customers are concerned about weight. Lithium ion phosphate is much lighter than a sealed lead acid battery. The battery life is much better. So there's a lot of products in our bag that we can sell to the customer. And if we don't have something that's standard, we can work with them on a custom solution.
So, Brian, is there anything else you wanted to ask Joel or Lisa today before we let them go?
No, I think we hit everything we want to discuss today.
And guys, is there anything else you'd like to share with the audience about this topic today?
No, I mean, I think Sega is a partner. I mean, if there's need for samples and things to support any of these design activities, then yeah, I mean, Sega carries a lot of these products that we were kind of alluding to in this conversation. So it's good.
Yeah, and I think as we mentioned, I mean, our battery offering allows us the opportunity to get into the customer in the beginning stages to help them with their power solution for the battery, and that would migrate onto the DC to DC converter. So it's a great solution cell for us.
So, Joel, can you let everybody know where they can learn more and where they can find out more about the product?
Sure. We actually have full documentation in our website. So if you go to us.lambda.tdk.com and learn about non-isolated products, we have a section for that. Or you go to our application page for robotics, then you could find additional information for the solutions that we offer, not just onboard, but also some of the off-board charging stations, power supplies up to multi-kilowatt levels.
Well, thank you, guys. Thank you so much for your time today. We do appreciate it.
Likewise. Thanks.